All right, welcome class. We are going to cover 1, 2, 3-point and multiple point perspective. We're also going to talk a little bit about aerial perspective. In this quick lesson today, the first one, this will be a first of a 3-parter, and I'm just going to cover the basic properties of multiple point perspective, 1, 2, and multiple point, and we're going to walk through a 1-point perspective. Linear perspective, or the perspective of lines, is what's illustrated in this diagram here. 1, 2, and 3-point perspective. In linear perspective, you have lines converging at a single point, or points in this case, and in this case here. Those points are called vanishing points. The point at which all lines converge. These 3 lines converge at a single point. These 6 lines converge at 2 separate points. These lines all converge at 3 separate points. So those different points are called vanishing points. This next slide we are going to talk about 1-point perspective. In 1-point perspective, I start off with a front plane of a box. And from all 3 corners, corner 1, corner 2, and corner 3, these 3 points are connected to a single point. This will give the box the appearance that it's going back in the distance. In this case, the view, the aerial perspective view of this, is below my eye level. So this is an imaginary line. If I'm 5'10", this line is 5'10". My eyes, maybe a little bit less, 5'6". This box is below my eye level from where I physically stand. Those are eyes. That's below. If it was at eye level, I would see just one side of the box. If it was above eye level, instead of seeing the top, I would be seeing the bottom. So what are some classic examples in 1-point perspective in terms of drawing? If you've ever stood in the middle of railroad tracks, this would be a good example of 1-point perspective. Those are the railroad tracks. The point at which they converge way off in the distance, maybe 15 miles down the road, are the point, or is the single point, where both the left rail and the right rail converge. The tracks in between, or the wooden slats, way off in the distance, they all seem jumbled together, and as they come out towards where I am standing, they start to spread out. The gaps in between are larger and then smaller as I go off towards that single vanishing point. Now in this little virtual world here on my drawing, let's say all the trees were planted at the same exact time. Then the tops of the trees along the sides of the railroad track would be the same height. So let's say they're about 40-year-old maple trees. Kind of grow a little bit slow, but they're still a little tall. And I should probably do that in green. So the tops of the trees and the bottoms of the trees all seem to converge. I drew my imaginary line at that one point in perspective. Sorry. Now you're saying I'm missing the trunks of the trees, and I am. Theoretically, those as well would appear to go to or pinch off at that single vanishing point. So let's say they're all perfectly 40 feet tall, and again, like the railroad slats, they're all jumbled, those trunks are all jumbled up in the distance, and as they come out towards where I'm standing in my picture, they start to spread apart. And on this side as well, all jumbled up towards the vanishing point, and as it comes out towards me, they spread apart. We'll say this is the space in between the trees here that I'm kind of shading in. Okay, now let's say you know that telephone poles are man-made. Let's say on the right-hand side of my railroad track here, I want to draw telephone poles. So I know that those are definitely going to be the same size. We'll make them red so they stand out here. This initial line was my perspective to gauge the height of those poles. Coming down the tracks here. There's your lines. And now your telephone poles are all the same height. So that'll end our first lesson here in one-point perspective on how it applies to a drawing. And that is the end.